Hello boys and girls, welcome back to the YouTube channel, or should I say welcome back to me. I feel as though I've been neglecting you for a little bit, and I apologize for that. But I've been busy building stuff, so why don't I take a couple of videos, catch you up on what we've been building, and take you through a FreeNAS storage build for an ESXi node. So without further ado, let's get into it. Alright, so as I just introduced, gang, we're going to talk about FreeNAS and ESXi. Before we get into the build, we'll talk about a little bit about, sort of how these components go together and where we are in the topology. So here is our starting set of components. Essentially, I have a computer and I put ESX on it. Remember that ESX is a bare metal hypervisor, and I am using vSphere to manage this particular host, and they're connected via a switch. I have chosen the 10net as my management network, so I'm trunking up to the ESX host. Now in this case I'm using ESX 5.5, and the reason that we trunk is so that you can have multiple VM networks and VLANs in the virtualized environment. My vSphere host is also on VLAN 10. Now along the way we've certainly added to our build here a little bit. So as you can see, I've got a couple of wired nodes out there in the world. So 192.168.2.2 and 3.2. These are just network nodes. They're in the physical world, and so these are computers that you can walk up and touch. I've got a router attached to the topology. We've got a couple of VLANs out there, and I've also added a couple of virtual machines or virtual hosts. And you can see those are the little computers in the ESX host. So 192.168.2.1 and 3.1. These are in VMnet 2 and 3 respectively. And they're also tied to that particular VLAN. So that 3.1 can talk to 3.2 and 2.1 can talk to 2.2. And of course this traffic is tagged over the trunk that's running between the ESX host and the switch. So that's how it works. And this is true regardless of how you set up your virtual topology. Now the router is there so that you can communicate in between VLANs. Now you can make the argument that that router can be anywhere, and you'd be absolutely right. So you can have a physical router. If you're using a multi-layer switch, you can route between your VLANs, or you can do something a little more interesting. We'll talk about that here in a second. Now part of this is what other kinds of virtual machines you might have out there. So we're used to things like server virtualization or creating some VMs for a development environment, something of that sort. But if you want to do something like network functions virtualization, you can have a VM or a virtual machine that actually does your routing for you. So we often use things like pfSense or Viata. Of course, Viata is taken over by Brocade now or bought out. You can even use a VM based on Linux and then just route between the interfaces if you want to work on that way. So you can get as interesting as you want with your routing, but essentially the deal here is that we usually put VMs into their own VM network, their own VLAN, and then you have to figure out how you're going to route between them. All right. Now a really important question when you start scaling up a little bit is, what do I do about storage? I've created all these virtual machines, and as we know, the ESX host, ESXi is a lightweight operating system. It's your hypervisor, but it has a small footprint compared to Windows or Linux or something like that, because you don't want to dedicate your resources to your operating system. And so you still have the ability to use your internal hard drive for storage. Well, what do you use it for? Well, it depends on how you feel about it. If you want to, you can certainly use your storage for your virtual machines and things like that, or as an actual data store for the data that the virtual machines are going to use. You might have files that you're going to share up. It just depends on what you're trying to do. But the internal data store usually has some limitations of some kind, depending on what it is. It might be performance. It might be the sheer size of the drive. It might be that you're worried about redundancy or some loss of your data. So these questions, how much room do you have? Can I do RAID? Can I put more than one disk in there? And then I get some redundancy, some error control. But what about the performance? What kind of drive do I have if I have lots of hosts hitting these virtual machines, or if I have a lot of virtual machines themselves and the virtual machines are doing a lot of things? How well does this particular box perform? And that's where we start to get into things like, well, how do I get this box to do what I want it to do? Do I pack it full of RAM? Always a good idea in a virtualized environment. But what do I do with my storage? Now, when we deal with storage, you have a couple of options. You have direct attached storage. That's exactly what it sounds like. You are connecting your storage very commonly to a SCSI interface, or you might even use USB attached storage. I mean, there's just lots and lots of variations on this particular theme, but it is exactly what it sounds like. You are somehow connecting the external storage directly to the box that is requiring the storage. Next up, we have a network of some kind. So if you're going to put your storage out there and connect it to the box but over the network, well, that's usually over a storage area network or a network attached storage. A lot of times a storage area network is associated with something really, really expensive. Now today, if you read about this stuff, more and more we see the two terms sort of converging on each other to where they almost mean the same thing. But a lot of times when you're in an upper scale storage configuration, then you're dealing with technologies like InfiniBand or Fiber Channel. What we're going to do here is the network attached storage. The hint, hint, wink, wink there was FreeNAS. And we are going to be using straight up Ethernet. The protocol that we're going to use to communicate is iSCSI. Now, iSCSI is just SCSI, but in a packetized form. And then, of course, the product that we're going to use is FreeNAS. Now, FreeNAS actually has a number of options for handling your storage. We are going to happen to build iSCSI. So here's the idea. We've got our standard topology there, and we know we've got our internal data store, but what we want is more storage. And so I'm going to connect FreeNAS to my network, and then I'm going to use, after I install FreeNAS, I'm going to use the internal drive on that box as an iSCSI target, and we're going to have the ESX host communicate directly with FreeNAS for the purposes of storage. So, and what we use the storage for is not important at this point, but for right now, we'll just know that we're going to extend or expand the storage capability of our topology here by installing FreeNAS. Now, that earlier diagram, you might say, well, wait a minute, isn't that storage going to compete with everything? And you're absolutely right. So there are lots and lots of different ways to set this up. I might take my ESX host, put another Ethernet interface in it, and connect FreeNAS directly to it that way. So this isn't technically direct attached storage. We're using a network to do that. We still need IP addresses and all that. But it is a dedicated link between my storage server, FreeNAS, and my ESXi host. Now, another way to do this is to build a different network. I install the same thing, an additional NIC in my ESX host, and then a separate storage switch, and I connect FreeNAS to that. And the advantage here, like the topology above this, is that I don't have to compete with anybody else. I don't have to compete with my other network data traffic, and I've maintained separate connectivity for my management interface. What we are going to do, mostly because I don't have a dozen switches that I can throw at this thing, and also because they give off lots of heat, and all this is in my office here, what I've decided to do is to keep the things separate so that I could understand the flow paths and that we could actually see the communications, and we were required to set up the communication properly as we would in those other topologies. But I'm just going to provision another VLAN. So I've got one switch here. I have my VLAN 11 is going to be my storage VLAN. My VLAN 10 is going to be my management VLAN. And then my vSphere host is also going to be my management host for FreeNAS. So a couple things here. Everything is going to work the exact same way. But the VLAN 11 is going to be dedicated to that storage communication, the iSCSI communication between FreeNAS and the ESXi host. The 10net is going to be what I use to manage my ESXi host and the FreeNAS. And so FreeNAS comes with a pretty nice web GUI, and so I'm going to use the same host that I used for vSphere. Now, of course, I've got a route between them, so that's not on this particular diagram, but I do have to manage the two networks, so that's pretty straightforward, and that's how we're going to go and complete our build. All right, next up, I'm actually going to do the phase 1 of the build, but I thought it'd be worthwhile to talk to you a little bit about what we're doing and why we're doing it, and I promise not to wait too long. I'll have a video up at the end of this week or the beginning of next, so that I won't leave you hanging and feel as though you've been abandoned. Hey, thanks very much for watching. Thanks for listening. Remember, this is networking. You can do this, and may your packets always reach their destinations.